Welcome back to my YouTube channel. Today we are diving into a super important topic for everyone working with machine learning. That is model evolution and how to handle unequal error cost in Python. I am going to explain it step by step in plain English so you can use it in your projects. So let's get started. Firstly, we are going to check model evolution using Python. So how the models are evaluated in Python. When we train a learning model, we need to check how well it works. So firstly, we will check that only that how it is working the working process of something. This is called evolution, as we are evaluating the process step by step. For example, does the model works correctly, predict its outcomes? Is it making mistakes? And if so, what kind of mistakes? One common way to evaluate a model is by looking at its accuracy, that how accurate the thing is, which tells us how many predictions were correct. But accuracy is not always enough. That's why other matrices like precision, recall, and F1 score come in. Don't worry, see examples soon. Or you can see here. The first one is the load libraries and data, that how we are going to load the libraries is. Then train a random model, forest model, then make participation, evaluate the participation. Let's see use Python. In Python we are going to do to evaluate a model. Well, a train random forest model and evaluate it step by step. Here's how it work in Python. So let's see here. First, we import the required libraries. We'll use sklearn for the random forest model and evolution matrices. So here we load the libraries and the data. Nextly, what we do here is train the model. Next, train the random forest model with some example data. Assume X is our input data and Y is the target variable. See here, we have trained a model forest. So X and Y you can specify here. Then in the next step, now we will do the model to predict outcome for data. So that what outcome the project or our model is providing here, we'll say or we will make some prediction about that. The last one we'll see here is evaluate the performance, that how the model or the project is performing. Finally, we check how will the model is perform. Let's print the accuracy and a detailed report. So if we'll print that, we'll get to know that how much the our project or the work is accurate or how it is working. This report tells us how the model performed for such or each class. For example, how well it detected positive or negative. I think it is understandable. Now we'll move for the accounting for unequal errors or error cost. Now, what happens if certain mistakes are more serious than others? Let's say you are predicting disease. Missing a patient with a serious disease is much worse than falsely predicting someone is sick. That's not good, na? In such cases, we need to adjust the model to handle this unequal error cost. Here's how we can handle this in Python. The random forest classifier. This is function only. Allow us to assign weights to classes. We will provide some weights for that whose weightage is more. We can tell the model to focus more on avoiding serious mistakes. In this, let's take the example for this. See, so firstly, what we did, use class weight for random forest. Then we are going to evolve with the confusion matrix, then the custom matrix. We'll go step by step only. In this example, what we did is we will assign a higher weight to the class where errors are more costly. We can use a confusion matrix to see how model performs. Then this custom matrix shows the total cost of the model error. So you can decide if it's the acceptable or not. No, according to the error modeling only, we can decide that it can be acceptable or not. If it is providing much more errors, then it is not the relevant. So to summarize this, what are the topics we are covered is that we evaluated your model using metrics like accuracy, precision, and call. Their accuracy, that how much it is accurate. Then we the precision, then recall, that how it is recalling the next functions and all that. And then in the other point, if certain errors are more critical, use class weights. We use the class weights, that we are providing the weightage to the classes, that how much errors are in